I'll show you why in a second. But we've got the using static system.console. All right. This is basically, you can kind of look at it that this is kind of the name of the folder that holds everything. It's kind of what a namespace is. All right. The name, it's just in class program because I didn't give it a name. And everything is happening inside of main. So you'll notice what I have in here. I've got a string called name, a string called age str, which is short for string, a string called an int called age. In fact, I can set that now to 0. I should have. A salary, that's a double, a string called salary string, a boolean called is married, and a character that's called mi for middle initial. I'm asking you this question. Please be honest. Is there anything in there in blue that doesn't make sense? Can you understand what kind of variables they are? All right. Then I go and I ask them some information. Let's just take it to right here. So it says, what is your first name? And it reads it in. Since it's a string, it puts it right into name. Then it says, what is your age? It can't put it right into there. So that's why I've got that age string. And then I say, this is what I forgot before. Convert it to an integer. And you've got your choice when you convert it to an integer. You can convert it to a 32-bit integer or a 64-bit integer. What's the difference? The difference is the range. Where for a 32-bit, it's like -9 billion plus to +9 billion plus, which I considered for an age to be plenty big. And for 64-bit, it's into the quadrillions or something like that. So if you were working with like the national debt or whatever, you might use something like that. Okay? That's not meant to be a political statement. It really is not. Then we do the same kind of thing for the salary. But notice for age, since it was an integer, we do a convert to int. For salary, since salary is a double, we do a convert to double. See that? Now, look on the screen, please. This is a double, meaning it can't have a decimal place. But what I want to show you, you're going to learn all this. I could have said, instead of this being a double, I could have said this, decimal, which typically is the way that you work with money. Watch what happens when I do this. And I click off of here. I'm surprised. I thought it would give me an error, but it didn't. Usually I think it wants an M there. M for monetary, basically. All right. But I'm just going to leave it the way that it is. All right. Then notice I did the other ones differently. See this line right here? I put, instead of having a separate call to read line, I put the call to read line inside of the call to convert. So I've got a method within a method. Does that make sense? And if it doesn't, this is what you're going to be building. So if it doesn't make total sense now, don't worry about it. All right. Then I did the same thing with the middle initial, and then I wrote it all out. Notice this right here. Everybody see this? I've got salary dot toString. And the reason I'm doing that, and I put a C in there, it means currency formatted for me. So it'll automatically put in a $sign, and it'll automatically put in commas for me. And automatically make it 2 decimal places. So notice if I run this now, and again, I wish I would have changed this on yours. For salary, it really should never be a hard-coded value. All right, what I'm doing here, you learned this last semester, is I am both declaring variables and initializing them. All right? And those are pretty good initial values. Strings, empty string. Numbers, 0. If I wanted to here, I could have put 0.0. Either one is fine. All right? Bools, false, characters. Notice I don't want to do this. Even though, yeah, I was going to say, it usually gives you an error when you do that. And it says, there is no such thing as an empty character. There is an empty string, but not an empty character. So you typically make that equal to just a space. All right. So when I run this, notice what happens. And it comes up and says, what's your first name? Jeff. What's your age? 62. What's your salary? I'll just say 50,000 again. All right. What's your marital status? True, because it's expecting a Boolean. What's your middle initial? P. Then it prints it all back out. Does that make sense? This is all the kind of stuff that you're going to be working on. All right. All right. I'm going to jump into chapter 2 then. Go ahead. The question was, with the Boolean one, that's a good question. I'm not positive. We'll try it. Well, now my name's F. All right. Let's try putting in true like that. It took it. It didn't blow up. That's a good thing. Doesn't appear to be. Okay. Which surprises me. In other languages, it is. All right. All right. So let's jump right into chapter 2. And I couldn't remember how to do that convert. I just Googled it. All right. I think I told you this last semester, but if you'd all please, just for a second, look up on the screen. I'm going to go here to Microsoft. I'm sorry, msdn.microsoft.com. That's the Microsoft Developer Network. So if you go out to this, msdn.microsoft.com. If you go out there, it'll basically, if you click in the search box, it'll answer any question you have about the language. So again, jumping ahead here, chapter 2 is on using data. So what do they show you here? Some of the stuff I just showed you, and that's why I wrote that program, because I just wanted you to at least have something that you can refer to. All right. It tells you how to declare a variable, how to display values. When it says use integral values, integral is int. All right. And that is a whole number. It can be a 32-bit whole number, a 64-bit whole number. There's even other kinds that can be used. All right. Floating point means it's a double or a float. It means it can have a decimal point in it. All right. Using the arithmetic operators, well, you already know what those are. Addition, subtraction, multiplication, and division. And just like we had last semester, modulo, which is the percent sign. It's the remainder. So 5 divided by 2, you typically say 2R1. The 1 is what you get when you say 5 modulo 2. That equals 1. That's the remainder. All right? Nothing new there. Using the bool data type, we just saw that in the program I went over with you just a second ago. That's true or false. Describe numeric type conversion. Well, that's what I tried to show you before the break and floundered with it. Using the char data type, I showed you that. Using the string, I showed you that. All right. What if we wanted to use a constant in here? If I go back to the program that we brought up, I don't know where I need a constant here, but let's just say, I can say here, I think, what is it? Const int, let's make it a double. Const double max sal equals 1. All right. That's how I create a constant. I use the word const, then the data type, then the name. It's not mandatory that you put the name into uppercase. It's convention to do that. All right. accept console input, you already know how to do that. So much of the stuff that's in here, we've already looked at. All right? And I want to mention, at the end of last semester, there are supposed to be 13 of you in here. All right? Tom's not here, and you're Justin, right? There's Jason. I'm sorry, Jason. There's a James, too, who did not show for whatever reason today. I'm thinking he's still in the class. All right? But all of you got an email from me at the end of last semester that showed you where my YouTube channel was. So if you do miss assignments, I mean, again, my policy is if you miss an assignment, or not, I'm sorry, if you miss a lecture, all right, that, whoops, I don't want that. If you miss a lecture, that you'll go watch it on YouTube if you want to get caught up on the material. That's right, I moved it. Okie dokie. So that's now in here. Well, let's see if I can get to it this way. All right, so this is a little ugly, but again, you already got this in an email. All right, that's the playlist. Okay, if you go out to that playlist, right now there are 42 videos in there. And what I have done is I went through all of the PowerPoints from your book. You can see my granddaughter is getting a hold of my computer now. All the PowerPoints for the book, and then I went over and I did example programs from every chapter. So those are out there. All right. And then what you're going to see after a little later today is this please read me first just basically says how it's set up. But number 2 will be the first lecture I did today. Number 3 will be the second, or it'll have the most current lectures. How's that? They'll all be right up there. All right. All right. The difference again between a constant and a variable, technically, a constant is a variable whose value cannot change. So, you know, I gave you that constant before. Maybe this would be a better one. So if you're sure you're working with something whose value will not change, you can make it a constant. All right? Now, you might look at that and go, wouldn't it be just easier to use 12? Yeah. But what if we had this? What if we just assumed right now that everybody has the same tax rate, and for all of us it's 34%. I'm just making that up, so we're just pretending that. And let's say that I'm writing a program on tax rates for the IRS, and it's got thousands of lines. Now, if it changes from 34 to 35, I only have to change it right there. I recompile the program, and boom, everything else has changed. That's why you use constants. All right, it's twofold. It can make your program more readable, and there's just a single place where you have to change the value of a constant. Right? Now, they talked about data types in here. We looked at these just a little bit ago, but if you look right here, let's just start these first ones that are right here, these that you see that go up to right here. Those, the ones that are here up to here, Those are all whole numbers. Does that make sense? Now, if you noticed before when I said age, I made it an int. I would have been better off probably making it a byte, because a byte can go from negative 128 to 127. I don't know how many, if any, one has ever lived where they're more than 127 years old. I really don't know. I don't care. I watched a little bit of the Golden Globes last night, and Michael Douglas won a Golden Globe for something that he's in, and he thanked, among other people, his 102-year-old father. You know, even that's not real common. All right? But the point is, these are all whole numbers. When there's an S in front of it, not in front of the word short, but this S means that it's signed. So notice the difference between these. A byte that they show right there, a byte starts at 0 and it goes to 256. An S byte is signed, so it goes from negative 128 to positive 127. All right? You asked this before, Christian. Notice there is a 32, and I guess I was wrong on the numbers I gave you. It's negative 2 billion to positive 2 billion. See that? And this is 9 times 10 to the 18th. I don't know how to read that. All I know is if I had that kind of money, I sure as hell wouldn't be here. All right? But those are all whole number types. The ones you're going to use in this class almost exclusively will be byte on a rare occasion, and an int, possibly a long. That's probably about it. All right. I don't know why you'd have reason to use the other ones. I'm not saying you couldn't. I just say offhand, I don't know why you would. Then the next set that's in here, these are all ones, these three, that can hold a decimal place. So what's the difference between a float and a double? Again, the proximity. How big a number can it hold? 3.4 times 10 to the 38th. Again, I don't know what that number is. I also don't know what 1.8 times 10 to the 308th is. All right? And they also talk about Unicode in here, and all that stuff matters is when you're comparing things. All right? That's pretty much it for the data types. And again, the ones you'll use almost exclusively in here, int, maybe an int 32 or an int 64, float, double, decimal, char, bool, and string. All right? When you declare a variable, it says, what do you need to do? Well, look at the example that's down here that I've got in blue. Int my age equal 25. All right? The data type is int. The name is my age. You do not have to put in an optional assignment operator to initialize it. If you don't initialize it, I believe its value is null. Unless you have a really good reason, you should always initialize variables. Even if they're numbers to 0, like I showed you before, strings to the empty string, booleans to false. All right? So int is a whole number. This actually should be read, take the value 25 and assign it to the integer variable my age. No one talks like that. All right? People say int my age equal 25. But the equal sign isn't equality, it's assignment, as it is in all languages. The author says it's better to use just int rather than int 32, basically because you have less typing to do. All right? I don't see, if you look up on the screen here, see where it's got int my age equal 25? semicolon, int your age equal 19, semicolon. I like that. I don't like this. I don't like this. All right? To me, that's just sloppy programming. So I will expect you to declare each variable on its own line. The variable name, the variable type, an optional equal or assignment operator, and an optional value that you're assigning it to. All right? Now, did you see this too? The author says here, watch the video. She actually does have a bunch of videos that she's made. I don't know if I can click from right here and get to it or not. Doesn't look like it. But I know that she's got instructions in here. I just left that there. Is that, all right? Yeah. I mean, no, it's okay there. You want to keep it till you get to class or whatever. Okay. You want it unplugged too then? No, it's all right. So how to display it? To me, I want us to go forward in here, not backward. So I just showed you a program where I showed you how you can display that stuff. All right? I mean, that shouldn't be a surprise to anyone. Double sum money equals 39.45. Right line sum money, it's going to give you 39.45. Again, we could have also made that a decimal if you wanted to do that. Now, see that? The money is, they're hard coding a $sign in there. I just showed you a better way of doing it in the example I gave you. All right, where I used the .toString and I used a C in parentheses with double quotes around it, which means put it in there as currency. Just so you see this. You're going to see it in a later chapter. But, let's see. Where I did this and I said C, see that? Yeah, I think I can say here F2. Take that? I believe so. And the only difference between that and the C is that should remove the $sign. That should just say floating point to 2 decimals. 567.89. And it does. All right. This is confusing. What I want you to do, if you would please, is look at this example that's up here. That's right here. When I highlight something, I get that box, and I don't want that. But look at this example. I'll put it up at the top of the screen here. All right, and then I want to try to explain it to you. I just showed you an example right here where I said you could take this and put a C there for currency, and it can be a capital C or a lowercase c. It doesn't matter. All right. Well, they're showing you something similar here. All right. But they're using what's called string interpolation. This value that's right here that's got to be inside of curly braces, don't worry about the $sign. That's just putting a $sign in there. But this right here, all right, that's a placeholder. And that means that's going to hold a value of some money. That's all. And if you say that's confusing, you're going to see this almost always when you try to do something in this language. There are a multiple number of ways of doing it. All right. I showed you one way. The author's showing you another way right here. Notice they've done it again here. Now they have two placeholders. 0, which holds some money, and 1, which holds age. All right. Again, if that kind of stuff confuses you, don't worry about it. Again, I understand what the author's doing here. I don't know exactly what thinks she's showing you. This variable alignment, if you want to line up everything nice in columns, see, let's say that I've got three values in here. I've got $1,000, I've got $100, and I've got $10. Everybody with me? And I format all of them to currency. By default, they're going to look like this. The next one may or may not be lined up. It probably is going to end up being like this. And the last one will probably look like this. All right. Either that or they'll be lined up on the left. If you want to force them to line up exactly the way you want them to line up, you can use this variable alignment that she shows in here. I mean, I look at that as being something that, who cares? All right. If you know how to program, somebody can always show you how to do that, or you can look online. It's no big thing, one way or the other. All right, again, ints are whole numbers. Byte is an int. S-byte, which is a signed byte, is an int. Short is an int. Unsigned short is an int. Int is an int. That would make sense. Unsigned int is an int. Long is an int. U-long for unsigned long is an int. And char, a character, is actually represented internally with whatever its number is, all right, in the Unicode character set. And she gives you a bunch of examples. Again, you're going to be working with this stuff, for lack of better words, up the wazoo. All right. Floating point, as we mentioned, they're values that can conceivably hold a decimal place. If I was going to try to represent the number pi, let's say I wanted to do a 3.14, what is it, 159 to 5 decimal places, I wouldn't make it an int. I'd probably make it a float. And the difference between a float and a double is how big the number is that you can hold in it and how precise that is to a number of decimal places. Also called significant digits. So as it says here, let's go backwards. A float can hold as many as 7 digits of accuracy. So as it says, if you put in there 1, 2, 3, 4.5, 6, 7, 8, 9, it would cut it down to here because that's 7 digits. It'll automatically round. On the other hand, a double can hold up to 15 or 16. Decimal, as it says, has got the greatest precision. Decimal should be used for money. Again, if I already told you this, apologize, but I'll always remember this. When I paid off a car once, I got sent something from the bank. A postcard, which at the time was about a dime, telling me I still owed 3 cents on my car. Why? Because whatever formula they used in there, it wasn't exact. I thought it was funny because they spent more money to tell me what I owed than what I owed. You know, I even thought, well, couldn't you guys have called me? Right? It was a while ago, so email probably wasn't that in vogue then. I don't know. Emailed me or whatever. All right. Now notice this is typically you'll use doubles, even though they're bigger numbers. If you use a float, you've got to put an F on the end of that. See this? Right there? It doesn't matter if it's a capital F or a lowercase f. But if you say float, variable name equal, and you give it a value, it must, when you declare it, it must have an F in it. All right? And the good news is that's the exact same way it is in Java. That's who they stole it from. And so when you get to the Java class, there won't be anything new. It says if you want to, you can put a D in, although it's not mandatory, after a double. I've never seen anybody do that. And it used to be mandatory that you put an M in for decimal. I guess now it's optional. You can write numbers in scientific notation. That would never be an issue in here. This is what I already showed you. I showed you the C for currency. I showed you the F for floating point. But if you look in your book on page 61, if you have the book, all right, they show you in this table that's here different specifiers you can use to format things. I'm going to expect that when you start doing this stuff, it's going to be rough. You know, again, if you remember back when you started driving a car, you probably didn't drive it as well as you do right now. And if you don't remember that, if you've ever had to learn a stick shift, driving with a stick, you probably, when you started driving with a stick, it probably wasn't real smooth. Again, here's your arithmetic operators. I don't really believe we have to talk about the first four, and I already showed you an example of the fifth one. All right. Just like you learned back in junior high math, probably, you do multiplication and division and modulo, because it's a type of division, before you do addition and subtraction, unless you use parentheses. So that's your order of operations. There are shortcut operators in here. Don't even remember if we had those in JavaScript rather. I believe we did. There's plus equals, minus equals, times equals, divide equals, and modulo equals. There's 5 of them. So in other words, if I type in this, let's say I have x equals 31. And later I want to say x equals x plus 17. Don't ask me why, but I couldn't write it like that. All right, it would put a 31 in there, it would give me 48. Or I can just write x plus equals 17. A lot less typing to do. Typically, that's the way most programmers do it. Most programming languages allow you to do that. Not only can you, there's the plus plus and the minus minus. Remember, if I say x equals 6, and then I say either plus plus x, or I say x plus plus, now x equals 7. Almost always that's used inside of a loop. We did a little bit of that last semester in the JavaScript class. Okay. Again, you will, if you weren't in that class, you will be using this. All right, don't let it throw you at all. She's got another video there on page 66 for the shortcut operators. I haven't watched any of her videos, so I can't tell you how good or bad they are. As I mentioned previously, as you start to go through this, if you find yourself struggling at all, I would strongly recommend that you go through where she's got these you do it's in here. Some chapters will have only 1 or 2. Some will have 4 or 5 or 6. And if you go through these, she goes through an entire program and does, I think, a very, very good job of explaining. You know, she gives you, you know, it's the old saying, tell them what you're going to tell them, tell them what you told them. It's kind of what she does in here. All right? I think she does a very fine job of that, too. Yes. And like I said, even going back here, there is something that's explained that's in the textbook. I don't know where it is, but where she's got these things in here like watch the video. She shows you in the book where it's all online. You can get to that stuff for free. All right. Here's our comparison operators. Again, the same ones exact same ones you used last semester in JavaScript. Please look on the screen. Notice double equals for equality. All right, always. If I do this, that example that's right here, 3 equal 9. If I do that and only put in 1 equal, guess what? it may actually take that. Probably going to come back and give me an error message because it thinks I'm trying to assign 9 to 3. All right, but if those are variables, if that's x and that's y, and let's say that x is 8 and y is 7, if I say if x equal y, that's true. Even if they have different values. Single equal means assignment. Double equal means equality. All right, and here, exclamation point equal, not equal to. Another you do it. Understanding numeric type conversion. Well, I'm going to make this real simple. You can see this chart that's here on whatever the page is, 72. The biggest, the one that's considered the biggest one wins. So if I try to add an int and a double, the double's holds a bigger value. So it converts the int to a double before it does the addition. I didn't show you this, but if you look up on the screen here, because you're all going to do this. Remember this program right here? So what if I come through here and run this again? And it's, first name Jeff. Enter your age. What if I come in here and I put in here, hello? You're all going to see this at one time or another. This is called the exception handler screen. And it's telling me, I don't know what you tried to do. It comes back with a very simple thing there that says, hey, you know what? Your name was in an incorrect format, or the input string, which was what? The age. Well, notice it still took that age string and it put hello, but when it tried to convert it over to a number, it couldn't do it. That's when the program blew up. We'll learn later how you can fix that. All right, so you can put in any input and the program won't blow up. It won't take bad input, but by the same token, it won't blow up when you give it bad input. You can also do what are called casting variables. So I can do this. If I try to do this, if I say float x equal 3.14159, all right, and then I say int y equals x, I'm asking you to guess. Will that work? Can I take a float, a number with a decimal place, and assign it to a whole number? Can I do that? The answer is no. But if I want to, I can do this. Instead of saying equals x, I can say int x. Then it removes all that. And it assigns 3. That's called casting. You're going to see that as we get into this. All right?
Does that say you just don't have to write a whole entire another line for 3?
No, that's because you're trying. It's like you're trying to stick oranges into an apple bag. And so what it's saying is, I'm gonna take that orange and, for lack of better words, make a copy of it, convert it to an apple, and then you can put it in the bag. All right, the character type we talked about already in single quotes. The escape sequence, the two you're going to use almost exclusively are \n for new line. I showed you an example, and \t for tab. All right, there are other ones that you can use. They might even show them in here. Yep, there they are on page 75. I don't think that I've used very few of these. All right, but I've used the ones I have used, like \n and \t. I've used a lot. Another you do it in here. Oops. There's a big word here. This isn't that big. But when two strings are compared, they're compared in a way that's called, it's a lexicographical comparison. All right? Easiest way to show you is like this. If I come through here and I have two strings, Mark and Mary. It compares these two. It says they're the same, they're the same, they're the same, they're not the same. Does that make sense? It does it until it finds someplace where they're not equal. That's what the lexical comparison that they're talking about here. That's what they mean. They give you some examples of that. This, I'll mention it to you now, but most people get confused. It says here, a string is immutable. And most people, when they hear that, they're like, I have no idea what that is. So if I come through here, and let's say that I put in here string F name for my first name equals Jeff. And then later on in the program, so someplace later on, they want my full name. So I change it to F name equals Jeffrey. All right. What this is saying right here about it being immutable is when I set this up, someplace in the memory of the computer, doesn't matter where, but someplace in the memory, let's say starting at location 1000, there's JEFF. It's not really JEFF, it's the zeros and ones the computer can understand. When it hits this line, what they're saying is, it doesn't just come over here and add REY. It goes to a different spot in memory, maybe at location 8000. And then it puts in JEFF REY. And then it sends a signal to the system, hey, this is garbage. You can't access that anymore. All right? And if that doesn't make sense, you're going to see it again as we go on. They talk about strings and substrings where you can find a piece of a string. It's no big thing. Name constants, I already showed. There's an example very similar to what I showed you. Again, I was taught when you can help it, never, ever, ever, never, ever, ever use, boy, oh boy, an underscore in this language. Just run them together. Right? If you don't agree with that and you want to write tax rate like that, I would never take off or anything like that. But it should be in uppercase. They're mentioning that you should come up with something like names like inches and a foot or whatever. I showed you an example of that. It makes your program more self-documenting. Talked about that earlier. You can create your own data types in this language. When you look up on the screen, that's creating a new data type that's called day of week. The only values that it can have are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. The values that it has must all be in uppercase. But you can create your own. Why would you want to use that? Maybe I'm doing some kind of a thing for somebody who's a botanist, and they want to have 5 different types of trees. I could come in there and do an enum that was called tree types, and I could put maple, elm, etc. if I wanted to do that. Typically, although you don't have to, if you're creating an enumerated data type, you take all the possible values and you put them in uppercase. All right, because really they are constants. Console input, I showed you an example of that. I asked the question before, what's the opposite of a write line? The answer is it's a read line. All right. There's that convert class that I look for. All right. On the program that I showed you previously, so notice what they're doing. They're using exactly the same way I showed it to you, with a read line, and then they're doing a convert dot to whatever. Again, I'm not expecting that all of this stuff is going to make sense to you right now. I'm not expecting that you're going to retain every bit of this. All right, that would be asking too much after 3 hours. All right. But I think over time you all will. Here's the different ways that you can do conversions. I showed you a couple.